So questions from the review worksheet, number 4. Great question. Let's see, r and theta. Theta equals pi over 6. There's nothing about what r is, so r I guess can be anything, because it doesn't tell me about r. So as long as I'm on theta equals 6, r could be 1 or 2 or anything. And that graph is half of the graph. What's the other half? Do you know? Backwards. If r is negative, I would rotate pi over 6, but then I go back the other way. So make sure you get the full line on that. So those are easy ones, but I don't know that we've done one yet. So good question. And then number 12 would be similar. Other questions from the review? Number 12. Theta equals 0. What do you think that would look like? Don't know, that's why you're asking. Let's see, so if I don't rotate at all, rotation equals 0. So I rotate none at all, it puts me on the positive x-axis. If r is positive. If r is negative, it puts me on the negative x-axis. That's a tricky graph to see since it's on the axis. No rotation. If theta equals 1, we wouldn't ask you to graph that because you don't know where 1 is. We would give you an angle that you know. Pi over 4, 5 pi over 6, something like that. I mean, theta equals 1 is on there somewhere, but I don't know how big 1 is as an angle measurement. Honestly, what I'm concerned about is not the most recent stuff, which is those graphs, but the older stuff, the back page, the parametric, because it's been a while. Yeah. Convert the given polar coordinates to Cartesian coordinates. Let's see. So x equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, tangent of theta equals y over x. That's our conversion formulas. All right, given the polar coordinates, so this is r and theta. Some people will just jump in and plug them into the formula. That's fine. I usually end up graphing them to help me visualize what's going on. Let's see, 2 pi over 3 comma 4 would be like right there. And so I'm looking for the x and the y. X is 4 cosine 2 pi over 3. Plus this helps me with cosine 2 pi over 3 if I have it graphed right there. That would be negative 1/2. Y is 4 sine 2 pi over 3. Sine of 2 pi over 3 is root 3 over 2. 2 root 3. So I'm not quite done yet because I want a coordinate pair. I mean, I've said what x and y are, but I want it as a pair. So negative 2 comma 2 root 3. And I think that matches my picture. Left 2, up 2 root 3. Again, the picture's not necessary, but maybe it helps. Let's do one from 34. Like B and C would be the same method as A there. On 34, you got a preference on A, B, or C? C it is. C's probably the most difficult. Numbers are weirdest. They're both negative. Let's see. So I'm going to go backwards negative 2 root 3 and down negative 2. It would help me if I knew which one of those numbers was bigger, because then my graph would be a little more to scale. So which coordinate is, I guess I should be careful, not greater than, because that accounts for the negative. Which one of those is longer, the x or the y? The x, because root 3 is bigger than 1, so 2 times something is going to be bigger than just 2. So the x coordinate is bigger, negative 2 root 3, and then the y coordinate is not as big. And so I need r and theta. Well, r is the easy part. X squared plus y squared. Well, I say it's the easy part, as long as you know how to square numbers. Especially 2 root 3, right? Square the pieces. 2 squared is 4. Root 3 squared is 3. And then 4 plus 12 is 16. So r is 4. And then maybe you can tell by looking what that angle is. I hope some of you can. If not, tangent of theta is y over x. All right, I'm going to reduce the 2's, reduce the negatives. I'm running out of space. Fix the root 3. So what angle has a tangent of root 3 over 3? Pi over 6. Yes. Is this angle pi over 6? No. What is that angle? 7 pi over 6. Again, the picture helped there. So 4, 7 pi over 6 for the polar coordinate. Let's jump to the back. I wanted to hit the old stuff. Yeah, the test looks very similar to this back page, or at least that section does. Right, x of t equals t squared minus 5. Y of t is t over 2. So 9 minus 5 is 4. Again, it's probably easiest to work a column at a time rather than going back and forth between the two equations. 4 minus 5 is negative 1. 1 minus 5 is negative 4. Negative 5. Negative 4. 1 and 4. Alright, just plugging in x. Plugging in y is even easier. Although I don't think I'm going to leave it as negative 3 halves. I'm going to write that as negative 1.5. Plug them all in. And then when it comes to the graph, I ignore the t column, right? This is an xy graph. No t involved. At least not on the graph. Let's see, 4, negative 1.5. Negative 1, negative 1, negative 4, negative 0.5, negative 5, 0, negative 4.5. Oh, there's some symmetry here. Negative 1, 1, and 4, 1.5. Okay, I think this is like a sideways parabola kind of thing. And that graph is not quite right. What's missing?
Arrows.
The arrows. right? Because if a t is involved, that means we started it here at negative t equals negative 3, and we went this way. So your parametric graph has some direction to it. So put at least a couple arrows on there. Find the rectangular equation by eliminating the parameter. X equals t squared minus 5. So t equals plus or minus square root x plus 5. So y equals, I'm going to be, I guess, lazy and just put in the plus or minus all in one step, rather than writing it as two equations. You could write them separately. You would need to write them separately if you wanted to put them in the calculator. But for us, we could just leave it as plus or minus. And I think, I mean, I can't check that exactly, but I know what the square root graph looks like. And I know what the negative square root graph looks like. So I feel like this is correct because it kind of matches the graph that we already drew. Consider the curve in the plane, number 40, given by x is this, y is that, right? Y is a function of x by eliminating the parameter. Okay, so what we just did, but a little bit harder, x equals natural log 2 plus t. Okay, how do I solve that for t? How do I undo the natural log? Involves an e. So I can either e both sides, but most people would say do the loop-de-loop thing. E to the x equals 2 plus t. So that means t equals e to the x minus 2. And then y equals 4 cosine t. So we'll take what t equals and plug it in for t. So y equals 4 cosine e to the x minus 2. That would be a crazy graph to do, but we don't have to graph it. We just had to do the equation part. Let's do 41. So 41 is the only calculator part of the test. So with calculator, that's the first part of the test. We want to be competent with the calculator, not just so that we can get the problem right, but so that we can get it done quickly and move on to the rest of the test. All right, you don't want to spend probably even 10 minutes on this problem. You want to be able to type it in, go find your answers, turn it in, and get rolling with the rest of the test. So go grab a calculator if you need one. Projectile is launched at a height of h0 feet. All that's just the intro stuff. We'll give you all of that again. A golfer hits a ball with an initial velocity and an angle. So x equals 121 cosine 27 times t. Y equals h0. What's our initial height for this golf ball? Must be 0 because they didn't really specify. Plus, you're usually hitting the golf ball off the ground. So h0 is 0. Fair warning, the one on the test, I don't think it's 0. I think it's somebody throwing a ball or shooting an arrow, so that the h0 is not 0 for the one on the test. 121 sine 27 times t minus 16t squared.
So for the calculator in the mode, we should have this on degree parametric?
Yes, both of those, that is correct. We want to be in degrees because our problem's in degrees. And we want to be in parametric because we've got a pair of equations. That's not really what pair means or parametric means, but Might help you remember. So 121 cosine 27 times t. 121 sine 27. Close carefully parentheses. And then minus 16t squared. And usually our window is, who knows, but that doesn't even look right. That doesn't look like the path of a golf ball. Let's change my window. Oh, t step 7.5. That means I'm taking, my calculator is graphing every 7.5 seconds. That's not very good. Let's go 0.1. And how long is a golf ball in the air? I don't know, 10 seconds maybe? Probably not even that long. We're hitting a golf ball, so I probably need to go more than 10. I don't know, 300. X scale could be 0, but sometimes you want to back up so you can see the axis clearly. Y min, I'll leave it at negative 10, even though I know it doesn't go down that far, just so I can see the axis. Y max probably needs to be more than 10. Does this ball get 100 feet in the air? I don't know. Again, it's a guess. That's not a bad guess. So I need my X to be bigger to see everything, and I could do it with a smaller Y. So let's go 500, and Y max maybe I can get by with 75. Let's see how that looks. Okay. I could fine tune that some more, but it's also good enough. I also noticed that after I saw everything, it kept going, like the little timer thing was still going up here. That's because it was doing more time. So I wonder if 5 seconds would be enough to look at. Yeah, and even less than that. But like I see what I need to see, so I'm through playing with it. Like I don't want to spend, don't spend 5 minutes trying to get the absolute perfect graph. Once you see what you need to see, then go with that. I think I'm also going to change my time step to be a little bit smaller to make sure I get the most accurate graph possible. Again, if you go too small, then it takes forever to graph, so you got to find that balance. All right, how far does the ball travel horizontally? So that would be, you know what? I'm peeking ahead, and so I don't have to trace all the way around. Approximate how high the ball goes, so I'll get that on the way to how far the ball goes. So I'm looking at my Y value to see where it is the highest. 47.1 to the nearest tenth, anyway. And again, I want to turn down my T step to get it more accurate. Did I turn it down too far? Now it takes too long. Maybe, but I'll get a more accurate graph. So.
How did you trace it?
So just the trace button. Oh, it put me back at 0. That's the other problem with a narrow time step. It takes longer to trace because you're walking through all of those little steps. But I'm going to feel good about this answer when I get there. Oh, there was a 47.15 in there. So 47.15. How far does the ball travel and how long is it in the air before it hits the ground? Okay, so both of those happen over here at the right end when y is 0. I'll need to know what x is and what time is. You might remember you could play with the table and get there. I just think the picture makes so much more sense. Okay, so I'm looking for when y is 0, and the closest I can get to y equals 0 is negative 0.36. x is, you know what, I better just call it 371, and time is 3.44. And time would actually be, would time be a little less than 3.44 or a little more than 3.44? Based on where that cursor is right now. Should be a little less, but it's more than 3.42, and it's closer to 3.44, so hopefully the time step on my answer choices is good enough where I don't have to zoom in and play around with that. Again, that's the calculator question. I think the only extra question is on the test is, at what time is the ball at the highest spot? So it's not an extra spot to find, it's just an extra value to record at the top. Okay, we've reviewed all the old stuff. And by that I mean the parametric and the conversion. Do you want to do some more graphs? Because these are all just jumbled up now. And I don't know which one you think is easier, but I would say whichever format you think is easier, do those first. So if you think it's easier to look at the graph and write the equation, then I would do those first, kind of get your brain warmed up, and then switch to the ones where you actually draw the graph. And it might be good to do that because you would also see lots of pictures and remind yourselves what those things look like. All right, that's a lot of pictures all jumbled up. Do we need to do some? Yes, no? Some of you are like, nah, I'm good. Others probably need to see some. There's roses and I guess here's the quick summary. If a line is just theta equals an angle. So that was number 4 and 12 on the front. A circle at the origin, that's just r equals 3 or 5 or 7 or whatever. And then we did roses, r equals a sine or cosine of n theta, where if n is odd, how many petals did you have? Yeah, you'd add n petals. If n is even, how many petals do you have? 2 n petals. And then sort of the special case was if n is 1, well, 1 is odd, so you have 1 petal, it turns into a circle. So like number 19, is that a rose or a circle? Sort of like, is it a rectangle or a square? Well, that was both. And then the last shape was the limacone, r equals a plus b sine or cosine of theta. A plus b was the farthest point. A minus b was the opposite point, I guess. I don't know what else to call that. And then just a was like the side points. So there's your graphing summary in one little piece there. I mean, there's more to it, but that's the gist of it. Number 19. So let's see. It's a one-petaled rose. So it's going to look like a sine or cosine? Sine. So something sine theta. And what will A be? No, N is 1. What's A? Negative 4. Negative 4 sine theta. The negative is what has it flipped over.
About 28.
28. What shape does that look like? Guess we could verify. It's 5 out all the way around. So you could just say that the R is always 5. Ty? Yeah. Yes, I kind of breezed through those notes rather quickly. And as always, cosine goes with x, sine goes with y. Yes. Ty, you got those notes down yet? All right, let me zoom out a little bit then, and now we can still do 23. Let's see. So that's not a circle. That's because that's kind of pushed in over up at the top. So that's R equals A plus B sine theta. In fact, it would be minus sine theta because it's pointing down. Okay, so the A plus B part, you know what? Do the A part first, right? That was the easy part. The sides. It goes 5 out on either side, so that's the first number. And then the add to number is this far point. 1, 2, 3, 4, 5, 6, 7. So what does this number need to be if the farthest point is 7? 2. That point is 5 plus 2. That point better be 5 minus 2. 1, 2, 3. So yeah, that's 5 minus 2. So there's, it's always, the more you know, the more you can kind of self-check and make sure you're on the right path. All right. Answers are posted. You sure?